Section 2.7 is going to discuss inequalities, linear inequalities, and we're going to start by trying to get acquainted with some of the notation. This is not too dissimilar from one of the questions on your next test, where I give you different pieces of information. For instance, I give you the inequality and ask for the graph and the interval, or I give you the interval, ask for the graph and the inequality, or I give you the graph and ask for the other two as well. But let's start out the first two. The idea is to try and get used to the difference between a couple of these things. And that is, we're going to first graph x is greater than -4. So, can x actually equal -4? Can this be true? No, it has to be greater than -4. So, we want everything to the right of -4, but not -4 itself. So, we'll put a little hollow dot there, and then an arrow to the right because we want everything that's greater than -4. If you want to borrow a ruler, I've got some up here. So everything to the right of -4, and most importantly, a hollow dot on -4. Now, how about the one below that? What's the difference there? Yeah, we've got a greater than or equal to. So in this case, we're going to put a solid dot on -4, and then again an arrow running to the right. Now that arrow running to the right means we're going to include all the points to the right of -4. But we're also including -4 as well. So that's the big difference in these two here. The circle means you're not including it. Solid dot means you are including it. So now let's turn over to look at the interval notation. For interval notation, it's always the left-hand endpoint to the right-hand endpoint. We're going to use brackets and parentheses in kind of a combination. In this first one, at the left-hand end is the number 4. Because we're not including that, we're going to use a parenthesis. What's at the right-hand end of this interval? I mean, if you go all the way out to the right, yeah, infinity. Infinity always gets a parenthesis. Yeah, thank you, -4. Now, how about down below here? We're still at -4, all the way up to infinity. But what's changed is that we're actually including the -4. So to show that we include it, we're going to use a bracket. So kind of down here, when using a less than or equal to or greater than or equal to, use a left-hand bracket or a right-hand bracket, and use left-hand parenthesis and right-hand parenthesis when using less than or equal to. Maybe I should have put that here. All right, let's move down to this one here. Now we want to graph the interval between -3 and 2. So let's think about that. First of all, what kind of a dot am I going to put at -3? Solid dot. Solid dot at -3. And a hollow dot at 2. So I want everything between there. And there's your graph. As far as the interval, as far as the inequality is concerned, that's -3 is less than or equal to x is less than 2. So typically when I grade a problem like this, it's going to be, 2 points for each problem. And one of the things I'll be looking at is, are you using solid dots or hollow dots, less than or equal to, or less than? Are you using the right signs appropriately? So why don't I give you a try. See if you can't figure out this one down here from -1 to 3. See if you can't come up with the interval notation. And again, that's going to be the left-hand endpoint to the right-hand endpoint, just like you read in English, from left to right. Then also see if you can't come up with the inequality. And it's going to be some value of x sandwiched between a couple other values. Jenna, you want to give us the interval notation, please? Okay, brackets or parentheses? Perfect. Bracket and then parenthesis. Good. How about somebody for the inequality? Someone there? Jessica? Perfect. All right, so the point I'm trying to get across is the nice correspondence between less than or equal to, solid dot, less than, hollow dot, and then brackets and parentheses, and again, solid dots and hollow dots, respectively. So are we comfortable with that conclusion? I mean, I'm hoping that these are like some easy points for you when you take an exam. Now, our goal in this section is going to go a little bit beyond just working with these inequalities. This is just kind of some of the notation that we use when discussing our answers. We're actually going to be solving linear inequalities. So we'll start out with some basic ones and then move up to some more challenging ones. We'll start out with problem 24. So x plus 5 is less than or equal to 2. Well, a lot of our work here is going to be just like it was in working with linear equations. The only difference is that this is an inequality. If I wanted to get x by itself, what do I need to do? Thanks, Ruben. Subtract 5 from both sides. X is less than or equal to -3. Okay. Let's throw in a couple other things along with that. Let's throw in the graph and the interval notation. I like to start with the graph because it gives me a nice visual of the left-hand side and the right-hand side. So I'm going to put a -3 on the number line. A lot of people feel some kind of pressure or desire to throw in the number 0. You can if you want. You don't have to for me. -3 is all I need. I know where 0 is. What kind of a dot am I going to use on -3? Solid dot. Which way am I going to shade? Which way am I going to find numbers that are less than or equal to -3? To the left or the right? So you want, now less than means smaller than, right? So smaller numbers are to the left or to the right? To the left. Good. So to the left we go. Now for me, it's nice having this graph written because visually that gives me a left and a right. Remember, your interval notation is always going to be in the form of the left-hand endpoint to the right-hand endpoint. So let's use our imaginations a little bit. You got to think, what's at the very left-hand end of that interval? -infinity. So -infinity and positive infinity always get a parenthesis. What are we going to put next to the -3? Bracket. Good. Let's put a bracket next to -3 because we're including the -3. Okay. Let's solve a couple more here. This is one that's on our handout. So 3x is greater than 4x plus 6. There's a couple different ways to solve this one. So one way to solve it is, personally I like moving the variable to the side with a larger coefficient. So that'd be moving the 3x to the right-hand side here. If I subtract 3x from both sides, Jacqueline, what do I get? What inequality pops out? Is there anything else? Anything else? All right. And 3x minus 3x is? 0. All right, so we get 0 is greater than x plus 6. All right, let's keep going. We still need to get x by itself, so what do? Yeah, we'll subtract 6 from both sides. So we get negative 6 is greater than x. Now, this one, I don't know. It's easier for us to work with the x if it's on the left-hand side. We'll come back to that in a minute. Let's see if we can't graph it and look at its solution. So I've got room on your handout for you. So here's negative 6. Am I going to put a hollow dot or a solid dot on negative 6? Hollow. Now let's look at things from the perspective of the x. How does x compare to negative 6? Is it bigger than negative 6 or is it less than negative 6? It's smaller. And smaller numbers are always to the left. Good. So put a circle on negative 6 and draw an arrow to the left. Smaller numbers are always to the left. With that drawn, try and write down for yourself the interval. What interval goes with that? In terms of the left-hand endpoint and the right-hand endpoint, what interval goes with that? All right, so what'd you get? What interval goes with it? The interval. Okay, good, except we need to list it in the other order. It's always the left-hand endpoint, then the right-hand endpoint. So negative infinity to positive 6. Negative 6, sorry. Thank you. Cool. So left-hand endpoint to right-hand endpoint. All right, are we okay with this conclusion here? Both of these? What if, back up here, you're looking at 3x is greater than 4x plus 6. What if you forgot my advice back when we solved linear equations to always move this to the side with the largest coefficient? Can we still get the right answer? Sure, but let's be careful. I'll subtract 4x from both sides. I get negative x is greater than 6. Am I done? No. What do I got to do? All right. If I divide by negative 1, then I'm going to get positive x is greater than negative 6. But wait a minute. That says something different than what I have over here. Something went wrong. And what went wrong is this. Whenever you divide or multiply both sides of an inequality by a negative number, you have to switch the direction of the inequality. So this is how it should look. I'll divide by negative 1. I get a positive x, a negative 6, but the direction of the inequality has to switch. It's an easy thing to forget. That's why forever and a day I've been encouraging you to move things to the side with the larger coefficient, because then we got a positive x and we didn't have to deal with that. All right, but here you have to remember to flip that. So it's up to you. Both of them work, but like I said, if you divide both sides of an inequality by a negative number, you have to switch the direction of the inequality. In fact, that's so important that it's a conclusion on your handout. right here. So make sure you switch things up if you have to divide by a negative or multiply by a negative. Okay. Are we okay with our conclusion on that one right there? Let's try some more here in terms of working with inequalities. Since we can use calculators, let's try number 40. 1.04 minus 7x is greater than 0.2. So we want to get x by itself. Any suggestions? Where would you start? You could add 7x to both sides. Sure. That would work. All right. Add 7x to both sides. Now, are 0.2 and 7x, are those like terms? No. So, okay. That's fine. I get 1.04 is greater than 0.2 plus 7x. That's a good start. Let's keep going. Now what? All right. Let's subtract the 0.2. If you line things up, that'll certainly help with your subtraction a little bit. Of course, you can always do that on a calculator. You should get 0.84. Now here's where it's helpful to have a calculator. If you don't have a calculator, a lot of us might feel comfortable multiplying by 100, but if you do have a calculator, take 0.84 and do what? Thank you. Divide by 7. So 0.12 is greater than x. So what I'd like you to do is graph that and come up with the interval notation. All right. Let's see here. As far as the graph is concerned, just put one number on the number line, 0.12. Solid dot or hollow? Hollow. All right, good. And which way is the arrow going to run, to the right or to the left? Well, take a look at it from the perspective of x. How does x compare to 0.12? It's less than that. So, in fact, if you'd like, you could rewrite it as x is less than 0.12. If you put your variable on the left-hand side of these inequalities, then the inequalities are going to point in the direction that your graph has to go. So, if the arrow is pointing to the left, that means your inequality is going to go to the left. If it's pointing to the right, it means your inequality is going to be graphed to the right. So, having the variable here is convenient. It doesn't always necessarily work out that way, but it is convenient. So we get everything to the left of 0.12. Ted, how about the interval notation? What would that look like? Well done. So parentheses around negative infinity up to 0.12 and parentheses around that as well. Well done. Yes.
Does it have to be negative infinity? Because I mean,
Yes. Yes.
the left, but it doesn't
It doesn't wrap around like Microsoft Word or something like that. It's negative infinity, and that's what's at the left-hand end point of this line, is negative infinity. if you wrote positive infinities out at the right hand end. So probably, yes. Yeah, so it is negative infinity there. I hope that's not too confusing. Okay. Now, you surprised me a little bit. I expected you guys to solve that a slightly different way. It would have worked just the same. In fact, you kind of thwarted me here, really, to be honest. What I wanted to do is I wanted to practice that little division trick. If you had subtracted 1.04 from both sides, you get negative 7x is greater than negative 0.84. How would you solve here? Yeah, divide by negative 7. And when you do that, what special thing has to happen? Yeah, you got to flip the inequality. All right. X is less than, actually positive 0.12. So, yeah, well done on you. I mean, we got the same thing. And you didn't even have to deal with that negative flipping the inequality. So, good job. Good job. Let me do a couple more, and then I might give you a chance to do a little bit. So, let me jump up to problem number, let me do 46. Even though it doesn't work out to be nice and even, that's okay. Let's take a quick look at problem 46. Five times 2 minus d is less than or equal to 3 times d minus 5 plus 3d. Okay, well, how would you start out? How would you suggest that somebody works on this first? Yeah, let's distribute here. So 10 minus 5d is less than or equal to 3d minus 15 plus 3d again. Are there any like terms I can combine? Yeah. 3d and 3d. So 10 minus 5d is less than or equal to 6d minus 15. Now here's decision time. Where are you going to put the variables? The left-hand side or the right-hand side? Right-hand side. Micah, what do I have to do to get the variables on the right-hand side, please? Add 5d to both sides. And what equation does it, or what inequality does that give me? That's a d. Well, 6 and 5 gives you... Yeah, it's well, negative 5 and 5 would give you, technically gives you 0d. But we ignore the 0 there. Yeah, just leave it as 10. So overall 10 is less than or equal to 11d minus 15. Almost done. 2 more steps. Yeah. All right, let's add 15 to both sides. 25 is less than or equal to 11d. And last but not least, divide by 11. 25 over 11 less than or equal to d. Do I have to reverse the direction of the inequality when I divide by 11? No. $25 over 11. Done. What kind of dot am I going to put on 25 over 11? Solid or hollow? Solid. And which way does the arrow run? To the left or to the right? D is bigger or smaller than this? To the right. Good. So I want to the right. Okay. Karanja, maybe you can give me some interval notation for this last one. What's the interval look like here? Good. Perfect. Perfect. Left-hand endpoint, then the right-hand endpoint. So, good job. Thanks, gentlemen. Are we okay with problem 46? Is that one looking all right? There's a couple more tricks that I want to share with you, show to you, and then I'll give you a couple problems to work on by yourselves, or actually in groups. The first one, let's try problem 76. No, 78, sorry. 78. So 4 is less than or equal to negative 4 times x minus 2, which is less than 20. One important thing, and you'll see this from me on a test from time to time, is that these inequalities are different. One's a less than inequality, one's a less than, one's a less than or equal to. That's going to stay consistent all the way out throughout the problem. It doesn't change. They don't both become less than, they don't both become less than or equal to. The way most people are going to solve this is to distribute here first. So let me kind of do the same thing. Distribute first. But what's different about this? This is a double inequality. So you have to be a little bit careful. We're going to have to work with all three parts of this inequality at the same time. Our goal is to get this x here by itself. So, yeah. Yes, perfect. So subtract 8 from all three parts of the inequality. That'll give me negative 4 is less than or equal to negative 4x is less than 12. Okay, so far so good. Then what? Any suggestions from there? Divide by negative 4. So I'll divide everything through by negative 4. Now, don't write this down just yet. Does anyone see something that looks wrong with the bottom answer? Right. But do you see what's wrong with the bottom answer? I mean, what looks wrong? I mean, does it... Well, it's saying that x is bigger than 1, but it's less than negative 3. So it's basically saying negative 1 is bigger than, or excuse me, 1 is less than negative 3, which clearly isn't true. So you're exactly right, Ruben. You have to switch the direction of the inequalities here. It's 1 is greater than or equal to x is greater than negative 3. That makes sense. 1's bigger than x, and that's bigger than negative 3. All is right with the world. Democrats and Republicans are best friends. So, but yeah, we'll see that tonight in the debates, I'm sure. Let's see if we can't graph this and come up with the interval notation. Graphically speaking, I typically only use the numbers that I have to use. 1 or 2 at most. So let's put some numbers here, a negative 3 and a 1. Basically what this is saying is that x is sandwiched between those two numbers. It's everything between those two numbers, but we got to be a little bit careful about the endpoints. So see if you can't put that down before I do, and try and graph this. Okay, so let's start with the endpoints. Kasnaya? Solid or hollow? Take a look at the x and the 3, negative 3. Well, because there's a greater than, use a hollow. And because this one is associated with x is less than or equal to 1, you use a solid there. So, like that. Do you want to try the interval notation? Now that we got the graph?
I know it'll be positive 1 with a parenthesis and a negative 3.
All right, so let's look back. What do we need in terms of brackets and parentheses? So brackets were for less than or equal to or greater than or equal to, and greater than and less than go with parentheses. So what interval notation should I put around this? Not both going to be the same, because one of them's got a hollow dot. There you go. So parenthesis and then a bracket. Good job. So there's all three different parts of our answer. There's all three different versions. There's the inequality. There's the graph. And the interval notation. Now, typically, I'm not going to want all three for every problem. We're doing that now just to practice things. I'll find out if you know all three different versions of this when I test you with a problem just like this. So make sure that you're comfortable with all these different notations. But typically when we're solving this, I'll probably just be looking for the inequalities. Tomer?
Over 28, the part with 4 and minus 4 times 8, no, yeah, okay. Why did you add minus 8 to the other side of the 4 by itself?
Well, you have to treat all three parts of this inequality the same. So here, here, and here.
Beside the 20, right?
Well, I subtracted 8 from here,
Okay.
so I had to do the same thing here and here. I have to treat all three parts of it the same.
Okay, but the result, it doesn't show like the 4 with the minus. Oh.
4 minus 8 is negative 4.
Okay. Yeah. Sorry.
Okay, not a problem. Anything else on 78 here? Yes.
When it's like greater than x, it's solid, or it's not gotta be.
Greater than or equal to is what gives you the solid. So that's why I got a solid here. And then a greater than give me the hollow. I could, if I wanted to, write it like this. I could just basically flip the whole thing around. Now let's be careful. It's going to be negative 3 is less than x is less than or equal to 1. Now, I know I always kind of blush with embarrassment, but it seems to help some people. Keep in mind the alligator eats the bigger number. All right? So if you look at these, the direction of the inequalities is really kind of pointing the same thing. The smaller number here is negative 3. The bigger term is x. And then 1 is the bigger term compared to x with the other part of the inequality. So you're just flipping it. And here it might make a little bit more sense, might be easier to read. Negative 3 is less than this, is less than or equal to 1. So your answer is trapped between negative 3 and 1. And that's what you see in the graph. It's everything between negative 3 and 1. Yeah?
Very tough of that problem from the very beginning. If we decided to, like, after we distribute it, if we just divided the whole thing by negative 1 to get the x positive, the inequalities, would that work too?
Sure. If you roll back the tape or you're watching this online, you can roll back. I said most people solve this by distributing the negative 4. But, you know, a different way you could have started this is just to divide everything by negative 4 right away. If you did that, If you divide it by negative 4, you have 4 divided by negative 4 gives you negative 1. Reverse the direction of the inequality. And then negative 4 and negative 4 here cancel. You're just left with x minus 2 is greater than negative 5. What's the last thing to do then? Add 2. If you just add 2 to both sides, or all three sides, you get 1 is greater than or equal to x greater than negative 3. So that's a different way to solve it. Most people probably wouldn't do that, but it is a good way to solve it. So, you know, if that works for you, great. Yeah, nice thinking. Okay, let's do one with some fractions, and then I'll let you try a few. I'm going to steal one of your homework problems. I know you're really upset about that. Probably going to get called out on social media, but I'll live with it. Negative 2/3 is greater than or equal to 2/3 or 2y over 3 minus 4, or minus 3/4, sorry. So the thing about this problem is that you've got fractions to deal with. And that's always kind of a pain for a lot of you. So what I would suggest is getting rid of the fractions by multiplying everything by the LCD. Now it's the LCD of all of these, 12. So it's going to be 12 times every term here. If it helps, you can think of it as 12 over 1. Now, one thing that I see quite often, I mean, not really all that often, but I see often enough, is people doing this. 12 times negative 2, oh, that's negative 24. It's true, but why are we multiplying by 12? What was our purpose in multiplying by 12? What did we set out to do? Yeah, we want to get rid of the denominators. We want to cancel them. So let's do that. 3 goes into 3 once. 3 goes into 12 4 times. Same thing over here. 3 goes into 3 once, into 12 4 times. And let's play that game one more time. Except this time, 4 goes into 4 once, and into 12 3 times. So we're cleaning this up. Victoria, what inequality do I get out of all this, please? Good? 9. Yeah. Good. Almost done. To finish up, what should I do? Add 9 to both sides. Good. Add 9. I get 1 is greater than or equal to 8y. Last step is divide both sides by 8. Do I have to reverse the direction of the inequality? No, because I'm dividing by a positive number, so that's it. Doesn't matter what I'm dividing into, if it gives me a fraction or whatever. Got a positive number, so we're good there. Let's graph it. Let's put the 1/8 here. Yeah, which, good. Solid or hollow? Solid dot. I want things that are smaller than 1/8, so that's going to be to the left. Well done. Tomer, what about the inequality? What's the inequality? Left-hand endpoint, right-hand point, that stuff. What's that look like?
So on the left hand, it's gonna be minus. You can,
Good?
and the other side, it's gonna be O1 over.
Bracket or parenthesis?
Parenthesis. Bracket. Sorry.
There you go. Bracket. Well done. Okay. Are you comfortable with 71 here? All right. Let me put you in a couple quick groups. Give you about 8 minutes. That's 2 minutes a problem. Finish up the handouts. So. All right, so go ahead and finish up the handout. Did I? Yeah. Thanks. Andrew and Lakendra, you need a handout. Thank you. There was a third one.
You had these three, and then you had these three, and then you put her with those.
Did I? Let's see. it? Okay, this is still a less than or equal to. Yeah, you've lost like this sign. It started out as a double inequality. Now it's just a single inequality. So that's a little bit wrong. And I think you misread your writing because 40 and 27 would be. All right, but there's another problem. 9 times 5 is 45. So you want to be adding 45 with all three parts of the inequality. So it should be 45 plus 45 plus 45. So it's going to be 72. I'll let you recalculate this over here. But you need to add 45 to all three parts of the inequality. So 45 here, here.
Figure out what happened with that one.
So what did they do to
Redo the whole thing.
We got a little hint on the board in case you don't have your calculator out. 2 over 15 is about 0.1333333. Just throwing that out there. let's finish this up. Come on. Come on. We'll start with the first one. I think most of you distributed the 9, and that's fine. If you distribute the 9, you end up with something like this. To get the x by itself, I'm going to add 45 to all three parts of the inequality. So 45 here, 45 here, 45 here, etc. When I do that, I'm going to get some cancellation in the middle. 45 and 27 gives me 72, and negative 18 and 45 gives me 27. Almost done. To finish solving, I get the 9, get rid of the 9, so I'll divide all three parts of the inequality by 9. So there's a cool mathematical operation. It's called gazinta, right? 9 gazinta 27, 3 times. And a gazinta 72, 8 times. So there you go. There's your final inequality. Let's graph it and take a look at the interval notation. Graphically speaking, it's going to be 3 is less than 8, or 3 is less than x, less than or equal to 8. So solid dot on the 3, hollow dot on the 8, and a little line between those two. In terms of the inequality, same two numbers, 3 and 8. What about brackets and parentheses? What do they get? Thank you. Bracket, parenthesis. Yay. How are we looking on that first one? Okay. Let's try the next one. So for the next one, you had fractions to deal with. The thing to do here is to get rid of the fractions. So I'll multiply everything through by the lowest common denominator. The LCD was 18. So it's going to be 18 times negative 2 ninths. 18 times 5 6. It's going to be 5x over 6. And 18 times 1/3. Now all of these are going to result in some cancellation. So let's see what we get. When 9 goes into 18, 9 goes into 18 twice. 2 times negative 2 gives me a negative 4. 6 goes into 6 once and into 18 3 times. 3 times 5x is 15x. And last but not least, here I'll get a 1, here I'll get a 6. Negative 4 is greater than or equal to 15x minus 6. What next? Plus 6. And that gives me 2 is greater than or equal to 15x. Divide both sides by 15. And 2/15 is about 0.133. So 0.13333, etc. is greater than or equal to x. Let's see if we can't figure out what the graph is going to look like. So 0.133, somewhere around here. That's going to be a solid dot because this is greater than or equal to. Is it going to be to the right or to the left? Let's take a peek back. This is smaller than this, so the arrow is going to go to the left. So 0.133, or better yet, 2/15. Last but not least, the inequality. Left-hand endpoint to right-hand endpoint is going to be negative infinity to 2/15. I'd much rather have the fraction as opposed to the decimal. Okay. I think the next two get even easier than the first two. So let's finish this up. Third one of these down here subtracts 7 from both sides. You get negative 5x as less than or equal to 5. Can anyone guess why I gave you a problem like this? Yeah, to remind you that you have to flip the direction of the inequality. If you divide both sides by negative 5, you end up with x is greater than or equal to negative 5. So that's the purpose in this one. So, excuse me, negative 1. Pardon me. Thank you. So -1 here, arrow to the right. Graphically speaking, we're all set. The interval is going to be -1 to positive infinity. Infinity and negative infinity always get parentheses. I'm not going to mark you wrong if you accidentally put a bracket on infinity or negative infinity, but they do get parentheses. Last but not least, this one's pretty straightforward. I would subtract 4x from both sides. Having isolated the x on one side somewhat, move the 1 to the other side, subtract 1, get 4x is less than -20. Do I have to reverse the direction of the inequality here when I divide by 4? 4 into -20 goes -5 times, but do I have to reverse the direction of the inequality?
No.
I do not, because you're dividing by a positive number. Doesn't matter that you're dividing into a negative number. What matters is you're dividing by a positive 4. So x is less than -5. That's going to be numbers to the left of -5. The interval notation is going to be negative infinity to -5. Bracket or parenthesis on the -5. Parenthesis. All right. For homework.
Do you have to worry about the back of that paper at all?
Now, the back of the paper, back of your handouts for section 3.1 and 2. More like, yeah, 3, 1, and 2. So for homework, section 2.7, it's on page 172. Try 27 through 55 and 65 through 83, and then a couple like 91 and 95.